Okay, so the 6.8 nodes are solar energy. And so let's find out what all you need to know about energy from the sun. Okay, so the first thing that you need to know about solar energy is that there's two different types of solar energy. There's active solar energy and passive solar energy. And so passive solar energy sounds just like the term kind of would make you assume is that it's just energy that is absorbed or blocked actually from the sun. So you're either absorbing heat or you're blocking the heat. And when I say heat, it's not, it's you're blocking the light energy. I like that better because the sun's heat doesn't travel through space. It's the light that travels through space. And then once it hits the planet, that light is then converted, light energy is converted into heat energy, okay? Either by absorbing it and then that light turns into heat or by blocking the light energy. So, and when the whole passive part comes in when you're either using you're not actually using any mechanical or electrical equipment to collect that energy, okay? So I think of like having a double paned window in your house that actually, blocks out some of the sun, or it actually within between the two panes absorbs that light energy within those two panes of glass and heats up. So the windows actually stay warmer than just having a single pane of glass, um, or having southern facing windows because the sun in the northern hemisphere where we live, the sun is going to be in the southern part of the sky during the winter. And so, especially during the winter, but also in the summer, it's in the southern, more southern part of the sky because we're, fairly high up in latitude. But having southern facing windows actually allows more sun to come in, heating it up. But then in the summer, if you have a roof overhang, it actually blocks out some of the sun from hitting your windows. And then also having deciduous shade trees. So in the winter, the leaves fall off the trees, allowing the sun to come in, heating up your home. But in the summer, you've got like big oak trees and big maple trees and elm and all these other things around your house that would have leaves that come out and then block the sun from hitting your house, which would actually keep it cooler. Having skylights in your house can actually decrease your electrical use. And then having dark colored flooring can actually absorb sunlight and create heat in the winter months. And then that wouldn't necessarily be a good thing in the summer months, but it's a good thing in the winter months to help heat your home. All right, so orienting just our building design to either block sunlight in the warmer months, but then allow sunlight in the cooler months is an example of having a passive solar heating system in your house. Okay, and then let me hide as we're talking, my picture there is we're talking about active solar energy. So that would be using mechanical or electrical equipment to capture the sun's light, which is then converted into heat. So having solar water heaters or having a concentrated solar thermal system, we'll talk about that. Or converting light rays directly into electricity with the use of PV cells or photovoltaic cells. These are all examples of active solar energy. So solar water heaters actually capture the sun's heat in the water, and then it circulates that warm fluid and transfers heat um, through that warm water for your home. So those are all examples of active systems. Photovoltaic cells are probably the most common piece of active solar equipment that we think about. And so we tend to just call those solar panels for short. They contain a semiconductor, which is silicon, which has to be mined, which is actually a drawback of solar panels. But the benefit is that this emits low voltage electrical current when exposed to the sun. So basically, the sun's rays, again, it's not the heat, it's the sun's rays, the photons hit the double layer photovoltaic cell, this semiconductor. It causes electrons to flow. And when these electrons flow, then they collected. That electron flow can be collected, and that chemical energy can be turned into mechanical energy. Um, and in this case, actually, we can, store this energy, and this electricity can then be used to just instantly be used if we have like cell phones plugged into a solar panel or something like that, or it can be used later if we have batteries that actually store that energy. So that's kind of a neat way that that works. And so energy, like we said before, kind of the transformations of energy that occurs. We have light energy from the sun that's transformed into chemical energy because of the electrons flowing within that semiconductor material that then turns into electrical energy. And so there's photovoltaic cells on a roof that can directly power a building, like I said, so that happens instantly. Or it can send electricity back to, they can actually take the electricity back at the electric company and can like spread it out to other users, and that gives you an energy credit from your utility company, which is pretty cool if you have a bunch of solar panels on your property. Okay. And so one drawback is something that we call intermittency. And what that means is that solar energy can really only be generated during the day, because it's not very cost effective at this point to create batteries, large batteries that can store energy at night. And so, or at least it's not cost effective on, the consumer level scale. So that's not something that we're able to do at this time, but they are creating, more and more technology to allow this to happen. So potentially in your lifetime, and hopefully in your lifetime, we'll actually come up with a way to make it cheaper on a large scale sort of purpose, to have panels that we can use and keep on our house at all times, or maybe even have solar panels on our rooftops of our cars, or there's lots of different things that we could do with better technology. Right now the batteries just aren't there yet. So once the batteries are there, that would be a viable option. When I talked about the term concentrated solar thermal earlier, and so this is when mirrors are used to reflect the sun's rays onto a central water tower in order to heat the water to produce steam to turn a turbine. So you can see, if we could do that, and we could do that on large scale, then we're able to create a lot of electricity from a solar farm. But a drawback is that it destroys a lot of habitat, as you can see by looking at the picture of this solar farm. And those light rays become very intense, which actually fries the wildlife in midair. So it's been known to, like, there's been a lot of dead birds that have been found at these farms, insects, because it takes them outside of their range of, survivability, essentially, and creates a lot of physiological stress that kind of kills them on the spot. So that's not a good thing. And then that picture kind of disappeared, and I was going to, well, it just really talked about the concentrated solar farm. Again, let me see if I can get back to that picture to see if there's anything I want to add. Not really. Understanding how this concentrated solar thermal farm works isn't such a big deal, but just realizing that it could be a technology we see in the future, I think is important. And then what's the difference between like having like a solar farm versus the rooftop solar situation? What I just want to give you an FRQ tip about this, and that would be that and rooftop solar would be like this kind of a setup versus like a farm setup. If you see anything about this on an FRQ, don't say solar panels. Differentiate between like rooftop solar or community. Like make sure that you're like, just don't in general talk about solar panels or photovoltaic cells. Like, are you discussing like the individual use of solar panels or PV cells, or are you talking about like at the community or large scale solar farms? Um, so just make sure that you differentiate between those two things. Large scale solar farms actually do generate lots of electricity, but they do take up land and cause habitat loss and fragmentation, whereas rooftop solar doesn't take up land, only produces just a little bit of electricity that's immediately used in a household's setting. So make sure you differentiate between those two things. Okay. And then what are some pros and cons of solar energy? Well, first of all, solar energy has zero air pollutants. There's no CO2 released when we generate that electricity. There's no mining of fossil fuels for creating the electricity. And it's renewable. So unlike fossil fuels, which will run out, it comes back every day as long as there's sun. So don't forget there is that intermittency issue. The solar energy cons would be that silicon, the semiconductor metal that is used, still needs to be mined. And so that's a major issue. So that there is a lot of, all the things that go along with mining any other resource would be involved with that. And so this can disrupt habitats, it pollutes water ways with the tailings. It can create particulate matter air pollution. And solar panel farms can also displace habitat, and silicon is a limited resource. So, silicon is used to make chips, like the um, semiconductor chips that we have in cell phones and things like that. It's also made to make most electronics in our on our planet. So once that runs out, what are we going to do? And I know that there's scientists out there looking for other ways to generate this stuff. So hopefully we'll come up with a more sustainable solution to that in the near future. All right, so practice FRQ for 6.8 is using this data below. Explain the relationship between the tracking ability of a solar PV system and its energy production. And you can kind of look at this down below. This is going to also combine with the information that we learned in Unit 4 with seasons. And so think about that as you're answering this question as well. Okay, all right, our next topic will be hydroelectricity, and I'll see you guys soon.